Great. So we will just go ahead and get started here. We have a very full hour, so I want to give as much time for the, all the time we need for the presentation. So we are going to get started here. So first of all, welcome everyone to the RePicture STEM Career Accelerator student final presentations. We're going to put a link here in the chat for the program for today's event. If you have trouble accessing that document, let us know. I think we have emailed it to everyone on this list. It was included in the invite, the meeting invite for today. But we've heard that some people are having trouble accessing that, but not everyone, so we can't figure out why. So yes, and you can always follow up after the meeting today, and we'll share that with you. So on behalf of the whole RePicture summer team, I would like to welcome you to the final event of our 6-week STEM Career Accelerator. I'm Elisa, and I'm one of the co-founders of RePicture, along with Lynn Mayo. We are very blessed to have Jerry Norman as a returning peer mentor this year and our panel moderator for the summer, as well as Jody Russell, our returning director of student success, who was also with us last year, as well as 4 amazing peer mentors, Jim Song, Asai Moreno, Lindsay Tatsumi, and Michael Fisher-Hagens. Together, this team and a few others working behind the scene has made our summer a success. So today, I promise we will get into the presentations. I know you are all here to see very soon. To give you all some context for the wonderful presentations you are all about to hear, I want to start by telling you a little bit about us and our Career Accelerator, so you have some context going into those presentations. And then we're going to recognize all of the award winners for our contest this summer. And finally, I'll go over a little bit of info and logistics for the breakout rooms, introduce our judges, and then we'll move into those breakout rooms to see the student presentations. So I actually want to kick off today by sharing the exciting news that this program that you are all now a part of is also now an award-winning program. We are this year's winner of the Women in Engineering Proactive Network Breakthrough Award, joining past winners that include companies like IBM and AT&T. So we are thrilled for this recognition of us and our mission to help students succeed in STEM. So although there are so many people that helped make this summer possible, I want to give a special shout out to 2 people who really helped get this summer's program started. Jody, who really helped get us out there and sharing with our community our story and what we're doing. And Natalie, who is instrumental in introducing us to Ashraf and helping to form our relationship with CSI, who is our lead sponsor for the summer. So we want to thank CSI, Computers and Structures, for making this summer's program possible and enabling us to offer it free to so many students from underrepresented backgrounds and to our partner organizations. We also want to give a special thank you to the National Education Equity Lab. I know a few of you are here today. They were a key partner in helping make our 2022 program possible as well. And we were lucky to have several of their students again this year, including one that you will hear from today. I would also like to thank Mose, who has been instrumental in helping connect our students with some incredible speakers this year. Mose is a great supporter of youth and of uplifting the next generation, and he helped introduce our students to Taj Eldridge on the topic of climate change, Jessica Burnett on digital health, Neve Donnelly and Hussein Sabag on robotics, Michelle Sika, who brought semiconductors to life for us, and Matthew Graysick on aviation. So some of them are here today, so welcome back, and we hope you enjoy meeting some of the students that you helped inspire this summer. So many of you who are here today know a lot about RePicture, and some of you are new to RePicture. So I want to share briefly with you about RePicture and about our very special and unique and growing community. So RePicture is a project-based community platform where students learn about people and organizations in the STEM world through actual real-world projects that are having a meaningful impact in the world all around us. So once they discover a project, they actively learn about it through the people and the organizations behind it. And in the process, they grow their STEM networks, make connections, and shape their future in STEM. Our growing STEM community is the reason our program has been so successful these past few years. And we're so proud to say that we've now had over 400 profiles created. I think it might be more like 500 now. We've worked with over 80 STEM mentors. Again, that might also be an underestimate by now, who have helped to provide over 250 hours of coaching to our students. And we've also been able to work with students from so many different backgrounds, including this year's amazing group of future STEM leaders. And because you've taken the time to join us here today, you're helping to make this community even stronger. So to give you a little sense of what we've done this summer, this is our calendar of events. RePicture, the RePicture STEM Career Accelerator is our flagship program where students are provided with one-on-one career coaching, mentorship, professional skills building, and the tools to create a personal portfolio of project research that will help them unlock opportunities and thrive in the world of STEM. So for the past 6 weeks, students have attended workshops while exploring different STEM careers. Each week they've completed assignments related to the skills we worked on that week, and they've entered their work into contests. Their presentations today are part of the last assignment of the summer. Today is our last day. They are giving 5-minute presentations on a STEM project that they chose and researched and published and added to their RePicture portfolios this summer. And with that, we're going to actually turn over to our awards ceremony. So yes, as I mentioned earlier, each week we have contests, and we've had a ton of fantastic entries. It was often very hard to pick the winners. I would like to present the winners, though, of our 2022 program contests. And I'll go through everyone pretty quickly today, but I encourage you all to go to RePicture and learn more about these amazing students and the projects they researched this summer. So they've really done an incredible job, and their projects are very interesting. One very special thing you will find on RePicture is what the students have done is they've taken sometimes these very complex projects. STEM professionals don't always take the time to explain what they do to the greater world, and they've really translated that, and they're helping to tell the story of STEM in a way that really anybody can understand. So I definitely encourage you to check them out. And with that, we'll go through the winners. So best written profile, we have Joshua, Guadalupe, and Madeline. For most inspirational profile, Julian, Jasmine, and Pernille. Best project you worked on, Julian, Averil, and Brenda. Best written reflections on a project you worked on, Pernille, Averil, and Brenda. Best interest project from an ambassador, one of our returning students, Hannah. Best interest project, Amber, Chloe, Catherine, and Joshua. Best written reflections on an interest project, Shanita, Catherine, Joshua. Best climate resilience project, Akib. Best digital health project, Averil. Best robotics project, Srinitha. Best aviation project and people's choice for our week 3, Brenda. Best project in an other category, Julian. Best team project in week 3, Neha, Jasmine, and Melissa. Best overall project in week 3, Anna. Best project based on an interview with a STEM professional, Amber, Chloe, and Kuzi. People's Choice for week 4, Julian. And finally, we have our best team project in week 5, Jasmine, Neha, Aaron, and Melissa. And you'll be hearing from this team actually today. Oh. So congratulations again to all of our winners this year. They've done an amazing job. And again, I'm really encouraged you to go and check out their profiles on RePicture. So congratulations. And finally, I want to recognize all of the students that participated in the program this year. We again, for the 3rd summer, had participants from all over the US and the world. So we'll drop a link in the chat to, actually we have a 2022 program page and where you can find all of our students and learn more about them and the projects that they worked on this summer. And you all can be part of that project page as well, the 2022 page. Everyone that provides feedback to our students today will be added to that page as program mentors. So we will always be connected by coming together here today. And now what we've all been waiting for, we are going to move on to the presentations. I'll go over just a few logistics first and welcome our judges. To give you a little bit of background, the students have chosen their STEM projects and they've researched, like I mentioned earlier, and published articles about them on RePicture. So after today, you'll be able to read more about their project as well as watch their presentations again on their RePicture project page, including those presentations and those students that actually chose to do their final presentation with a video instead of presenting live today. Today, our students are also competing for our final contest of the year, Best Live Presentation. And presentations will be about 5 minutes, plus or minus a little bit, and then 8 minutes for teams. After that, we'll have a few minutes of Q&A. Questions are highly encouraged. Our students love to hear your questions, and we have some very interesting topics today, so I'm sure you will have lots of questions for them. During that time, you will also have an opportunity to provide feedback. Feedback is also very welcome. The students really get a lot out of that feedback. So we'll give a link to the feedback forms in the breakout rooms. And you can also find a link to those feedback forms in the program for today that we shared with you earlier in this presentation. So today's student presentations will be judged on visuals, stage presence, and clarity of presentation. And you'll see all of that in the feedback form itself. You can also, if you'd like, just email us your feedback. You don't have to use the form if you're not able to access it for whatever reason, or use it with the device that you're on. You can always just email us your feedback as well. And last but certainly not least, before we go into the breakout rooms, I want to welcome our judges today. Thank you so much for supporting our students. We will introduce all of you just a moment when we go into our breakout rooms. And with that, Asai has assigned us all to breakout rooms. So we'll move over there now. Thank you again, everyone, for joining us for today. We really look forward to sharing your feedback with the students and to following up after today to let you know who the winners are of our final contest. So bye for now, everyone, and see some of you in just a moment. Yes, so again, I'm Elisa, one of the co-founders of RePicture, and I'll be the moderator of this breakout room. So I also want to introduce our peer mentor, Michael, again. He'll be helping with the logistics of this event and making sure we stay on track with the time. So I want to introduce and thank the judges for this room, for joining us and for supporting our students again. So we have Quanitra Hollingsworth. She's a WNBA basketball player with an MS in computer science and a BS in mathematical sciences and operational research. We also have Kristi Sattler. She's a senior structural engineer with the American Institute of Steel Construction. And finally, we have Willie Crump, who's an IT manager. The students will be scoring the presentations. The judges will be scoring the presentations to determine the contest winner for best live presentation. And each of you also has the opportunity to provide feedback to the student. As I mentioned, we put the link to the program in the chat again here in this breakout room, and you can find a link to the Google form in there as well. So we'll get started with the presentations. I'll first introduce each of the students, then they'll give their presentation, and then we'll have a few minutes for Q&A as the judges complete their scoring. And again, students love to get questions about their projects. You can put your question in the chat or raise your hand and unmute yourself, or just unmute yourself to ask your question. So first up, we have Joshua Odiasi. Joshua is a rising high school senior interested in both the STEM fields as well as the arts and humanities fields. He wants others to know that you should never let anyone, a teacher, a class, a friend, a job, an internship, the environment, a family member, or life deviate you from your goal, which I think is great advice. So with that, I'll turn it over to Joshua. Would you like to share your screen and your presentation?
Yeah. Does everyone see that?
Looks good. I can see it.
Okay, so hello everyone. My name is Joshua Odiasi. I'm a rising senior, as she said, and my project is on de-extinction, if possible. If so, should we? I chose this topic because I believe this issue will garner more attention in the coming years, because the most prominent ways humankind affects the environment is by causing or accelerating the extinction of other species. Scientists estimate that 5 billion species have gone extinct to date. To elaborate, if you have read the news or seen a weather report in the past months, you would have seen that our country is reaching historical highs alongside other countries around the world. With the world getting warmer, glaciers melting, invasive species forming, and animals not suited for the inhospitable weather face extinction, we are truly in a dire predicament. Currently, there's an estimated 100 to 200 species that go extinct every day, including plants, mammals, birds, and insects. And to put that in perspective, even if you do not realize it, we're experiencing the sixth mass extinction in Earth's history, and it's called the Anthropocene or Holocene extinction, and it's happening 80% faster than ever before. So I might have misdirected you a little with the subheading. It's not per se resurrecting, more so creating proxies. You can think of them as clones, but not like identical. All de-extinction requires it for it to become reality is a DNA, an embryo, and a birthing mother. But the main impediment to de-extinction today is DNA. Unlike in entertainment, such as Prometheus, Pandora's Box, or Jurassic Park, DNA is pretty delicate, and it's depicted to have unrealistic longevity when that can span millions of years. But on the contrary, it only has a half-life of just 521 years. Well-preserved tissue is usually fragmented the longer it's preserved. And since DNA is microscopic, it's harder to reassemble. And it's unclear how the order of genes should be reconstructed on chromosomes, making this ambiguity could have alterations in behavior and other character traits. Given cloning is hard, but precise genome editing, such as CRISPR-Cas9, Magotol, and Talon, alongside selective backbreeding, which is restoring ancient traits from extinct species by selectively breeding individuals and other species today that still have their genes. Even if genetic engineering and selective backbreeding are successful, they would have created a kind of hybrid rather than a pure resurrected species. We have actually brought back one species from extinction. If you see on the top left, in 2003, scientists brought back the Pyrenean ibex, which went extinct in 1999. Scientists preserved the cells and injected into goat eggs. Out of the 7 surrogate mothers, 6 ended in miscarriage, but 1 mother actually carried a clone to term. It suffered from asphyxiation 10 minutes later. Sadly, for those hoping out there, dinosaurs will not be part of the extinction most likely, because the chemicals needed to bring back a dinosaur have either turned into rock, and the genome to replicate another DNA there's not a genome to replicate DNA, so we can't really make a hybrid today. Also, there are teams and initiatives who are setting out to bring back these species lost to history. George Church, a geneticist at Harvard, is currently working on bringing back the woolly mammoth. As mentioned, he isn't entirely resurrecting the woolly mammoth. He's more so as making a hybrid. He and his team are hopeful for genetically editing the mammoth genes into Asian elephants. And also a genetics researcher and professor at the University of Copenhagen is leading a team of researchers to de-extinct the Christmas island rat, a species that went extinct in the late 19th or 20th century. The problem was that 5% of the genome was missing, which related to immunity and application, two highly important functions for an animal to survive. And another possible species is on the top right, is the passenger pigeon that went extinct in 1914 by being killed and hunted outright. Extinction of key species can cause ecological imbalances, especially if done rapidly. De-extinction can become a powerful conservation tool, rescuing ecosystems from collapse or preserving delicate balances. These targeted species introduction can be part of a geoengineering or climate change mitigation effort, as in the case argued for the reintroduction of the extinct Megafauna in the Arctic. However, the introduction of extinct species into an ecosystem will have complex and unpredictable results and effects. Most people perceive them as negative. And so they say the opponents of de-extinction say the benefits are largely outweighed by the negatives. Another counterargument is based on the methodology that would be used to bring an extinct animal back to life. The main argument against de-extinction comes from a conservation biology point of view. Focusing on de-extinction could comprise biodiversity by diverting resources from preserving ecosystems and preventing newer extinction. It could also reduce the moral weight that extinctions for reviving an extinct or an animal or plant back to life. The issue touches on a relationship with nature, finiteness, and how life and death are perceived. The sentimental factor plays an important role, whether on either de-extinction is good or bad for the environment, or if we're trying to revive the passenger pigeon or not repeating past mistakes. The process can teach us more about environmental dynamics, animal genetics, and development biology and genetic engineering. I like to believe that even though with opposing sides on both sides, I believe if we do come to a conclusion about de-extinction, it will be a well thought out process with a broad societal consensus. And that is my presentation, and here are my citations and articles that I got my work from.
Wonderful. Thank you so much, Joshua. Round of applause. Great job. So I actually got the preview and got to ask some questions yesterday. So
Yeah, hey Joshua, this is Willie. Yeah, I had a couple actually, but I'm just gonna try to stick to one. I had some flashbacks of Jurassic Park when you said the benefits of de-extinction outweigh the negatives. So one of the weaknesses, I think it was it unstable, the first one?
I said I said there's a view on the opposing side that say the negatives actually outweigh the benefits.
Okay. Okay. All right. Yeah, I was just thinking when the instability was the first weakness, and yeah, so it's like you don't know what you're bringing back, but okay. All right, that was just a flashback.
great. Any other, Matthew?
Yeah, so I'm sorry, Josh, I missed your conclusion. Was there an opinion that you had on this?
I said it wasn't more so of an opinion. It was just that I believe that de-extinction, if we do come to a conclusion about it, I believe it will come from societal consensus after there's been a long debate on it. I didn't come to dissuade or persuade people if de-extinction is bad or good, because in my personal opinion, I think it depends on the species you plan on so-called resurrecting, and also on the environmental ramifications it might have.
And I missed. So there's no real genetic engineering that's going on here. You're not modifying a species to bring it back. You're just basically growing it again from DNA. Is that the way it works?
I mean, if you want to consider CRISPR-Cas9, it's more like cortisol editing and implanting. As I said, you need a DNA, an embryo, and just a birthing mother. And most species have a birthing mother and embryo, and it just matters on the DNA. So, and now that you have CRISPR-Cas9, which is a genetic scissors, which you can basically edit the DNA microscopically to like almost the point of T. It's almost a reality. It just comes down to when it will happen and if people want this to happen.
Stick with STEM, buddy. You're going to do great. Honestly, stick with it.
Yeah. We probably have time for one more question if anyone has another question.
I'll ask you a question, Joshua. So it's if you in your research, is there any particular species that you think this is important to bring back? Are there any top priority species where that would be necessary?
They're trying to bring back the passenger and pigeon because they think since birds are really becoming, as I said, there's 102 species and primarily birds are actually getting killed more than other mammals. So that's why they think about bringing back passenger and pigeons. It might offset that balance, but it kind of depends on, will they be able to survive this heat? And that's one of the questions that people are posing to the extinction. That's why I said the more questions we pose, the better of a result we will have in the long run.
Great. Thank you, Joshua. And thank you everyone for your questions. Great presentation. Again, I think we all enjoyed it very much. And now we're going to move on to our second presenter today. We have Brenda Yan. Brenda is a rising junior in high school who is interested in expanding their understanding of the world through physics and finding a way to turning those interests into a career path. Brenda's intrigued with physics because it is just amazing how a set of laws functions as the order for an intricate universe. And with that, I'll turn it over to Brenda. Would you like to share your screen and your presentation?
Sure, give me a second.
Yep. And while you're doing that, I'll also mention we do have one additional presenter today who is not, unfortunately, on the program, Jennifer Liu, so she'll be next. And we'll send you her bio and information after today.
Okay, so hello, my name is Brenda Yan, and today I'll be discussing the natural acoustic camouflage of moth wings and the University of Bristol's research on its soundproofing capabilities. Now, many of you may think that moths are the drab, light-attracted versions of their butterfly cousins that frequent the lamp on your porch. However, as unsuspecting as they seem, some moth species have evolved sound-absorbing microscopic scales on their wings, giving them an acoustic invisibility cloak that helps them avoid getting eaten by bats. Bats use echolocation to navigate their surroundings and hunt their prey. To do this, the bat emits pulses of ultrasound, which is above the hearing range of humans. The bat then listens to the reflected sound from nearby objects to locate its respective position. When bat sonar hits the scales on a moth's wings, the scales vibrate instead of reflecting sound. This happens because the scales have resonant frequencies in the range of bat sonar. All objects have a resonant frequency, which is the natural frequency at which they vibrate. When the scales vibrate, it uses energy from the bat's sound wave, leaving little to no energy in the form of the sound that is supposed to return to the bat. Without the returning sound, the bat cannot locate the moth. These scales come in various shapes and sizes, and because an object's resonant frequency depends on size, shape, and composition, one wing can absorb over a wide range of frequencies, from 20 to 80 kilohertz or even higher. As you can see in the scanning electron microscopy images to the right side of the screen, the top shows a cross-section of the wing with two base scales in pink and a cover scale in yellow. The individual base scales are paddle-shaped, such as the one shown in the middle image. A closer look at the internal microstructures reveals the ridges and the cross ribs of the base scale, shown at the bottom. Now, the question is, how do the wings function when they're covering a hard surface? To be potentially used in soundproofing applications, the wing must still be able to absorb sound against a hard surface. Researchers at the University of Bristol conducted a study to answer this question. In their experiment, the sound is projected at an aluminum disc covered by a moth wing sample. Aluminum is a very acoustically reflective material, and this means that it virtually reflects all of the incoming sound. The researchers measured the reflected sound with the wing and compared it to the amount of reflected sound without the wing to calculate its effectiveness in sound absorption. To their surprise, the researchers found that the moth wing layer reduced the reflected sound by up to 87%. Remarkably, the moth wings have such capabilities with a thickness of only about 663 micrometers. Now, conventional soundproofing tends to be bulky to be effective at low frequencies because it uses porous, low-density material to dissipate the energy of the sound as it travels through. In contrast, the wing membrane traps the moving air as the motion of the scales uses the sound wave's energy, and this allows the moth wings to absorb sound using much less material and much less space. Conventional soundproofing can only absorb wavelengths equal to or less than 10 times its thickness at low frequencies, while moth wings can absorb wavelengths as long as 50 times its thickness at the lowest frequency tested in the experiment. To illustrate, this is how thick existing materials must be, and this is how thick the moth wing must be to block their respective target frequencies. The amount of space that bio-inspired soundproofing could save is especially valuable in architecture. High-performance acoustic coatings for buildings, vehicles, noisy machinery, and military operations can be developed by adapting these scale structures to absorb frequencies in the range of human hearing. In the end, even in a creature as unsuspecting as a moth, nature has prevailed in creating something that human engineers have long coveted. Thank you.
Wonderful. Thank you so much, Brenda. Great job. Again, round of applause. And this is again a presentation that I was fortunate enough to see before today and ask my questions. So I'll just open up the floor to questions. Does anyone have any questions for Brenda?
I will, if you don't want to dominate all the questions, but I'll ask a quick question, which is, have people tried to simulate this in a practical way, you know, with synthetic, material that they put on a wall and kind of see if they can replicate that cloaking ability or the soundproofing ability in a commercial context or just even in the lab?
Oh, well, the study that the researchers at the University of Bristol conducted was actually during this month in 2022. So the discovery is really recent, and they still haven't fully understand the exact mechanical, the exact mechanics of the sound absorption of the moth wing. So, in order to adapt that for frequencies in the range of human hearing would take some time because of how recent this discovery is.
So I think for bats echolocation, they have a very specific frequency range that's pretty narrow. So if there's resonant frequency in these fibers, it's going to work, but the human ear is from 20 hertz to 20,000 hertz. So, there'd have to be a wider range of resonant frequencies. So there'd have to be, like more variability in that frequency for it to work for human ears versus the narrow band for a bat. Is that part of that research? Is that being resolved?
Well, I think, okay, so conventional materials such as acoustic foam, which is really commonly used, they used a really porous material, a porous low density material in order to dissipate the energy of the sound waves, right? But for the moth wings, the mechanisms of the sound absorption are a little different. Instead of using like low density material for friction to act and decrease the energy of the sound wave, they actually they match, like the scales on the wing match the resonant frequency of the sound that is the incoming sound. So I think like the main structure that they're adapting is, or the main thing that they're trying to do is to replace the use of like this low density material with structures that have the same resonant frequency. And just by doing that, you could save, like you can completely change the approach to soundproofing and also, yeah.
Brenda, I have a question for you. So if you were on the research team that's studying this and trying to take it from this little research project into reality, what are some of the steps that you think you would need to take to make that transition?
As I said earlier, the exact mechanics of the sound absorption are still not fully understood. So I think the logical place would be to start there. So far, what the researchers have found out is that when they removed one side of the scales, because the scales are on both sides of the wing. So what they found out is that when they removed one side of the scales and they put the wing, when they put the modified wing on the aluminum disc with the scales in between the disc and the wing membrane, the scales actually create air gaps, and the overall result is really effective. It blocks from about 80 to 90% of the reflected sound, and they think that this is because the air between the they think it's because the scales create an air gap between the disc and the membrane, which traps the moving air, when the air is trapped there, the scales in between the disc and the membrane can vibrate, which transfers the kinetic energy of the sound into the motion of the scales. As I was saying, I would focus on defining exactly what type of what each part of the wing does in order to absorb sound, and also I guess expanding the range of frequencies it can absorb by experimenting with the different size, shape, and composition of scales, or the synthetic scale structures that we might develop in place of that.
Thanks.
Awesome. Thank you. Thank you, Brenda, again. And thank you all for your questions. That was very interesting. And I learned even more about this project today than yesterday. So great job. And now we're going to move on to our next presentation. We have Jennifer Liu. She's a rising sophomore in high school who is exploring different fields in STEM in order to find their career path. So Jennifer has the desire to better the environment and combat climate change. And Jennifer, you'll have to correct me if I mispronounce your name, but I will turn it over to you. So you can go ahead and share your screen and your presentation.
Okay. Yep. Sorry, hold on.
It's okay. And yes, thank you, Matthew. We actually, Jennifer is there, but just the 4th, right, Matthew? Is everyone seeing Jennifer on the feedback form?
Yeah, I'm seeing
okay.
Jennifer as the 3rd presenter for this group. I'm sorry, I'm seeing Cuthrell.
Oh, yes. And then, but do you see Jennifer after that?
Nope.
No. Okay. Okay. So for Jennifer, please, we'll actually send you a form.
Dad, go
for feedback for Jennifer after today. So sorry about that. Yeah, and maybe we'll just Jennifer, should we go to Ethan and come back to you? Would you like us to? I want to make sure.
Yeah, sorry about that. Is it okay if I go last? I'll figure out my screen sharing.
Yeah, that's fine.
Okay. Thank
So
you.
well, Ethan, are you ready to go?
Yep.
Okay, great. So then our next presentation will be from Ethan Cuthrell. So Ethan is a high school student with an interest in computer science and in creating their own games and apps. So Ethan wants to learn computer science because it will enable him to help others in more ways. And with that, I'll turn it over to you, Ethan.
Okay. Okay, I think that should be good. Can everyone see it? Okay. So My name is Ethan Cathro, as you heard, and my presentation is how snotbots can help combat whale endangerment. So a snotbot's job is as gross as it sounds. Snotbots are drones that use artificial intelligence learning to collect snot samples from whales. When a whale surfaces to breathe, it shoots moist air from the body containing its snot into the air. And when a whale does this, the drone can fly through the vapor and collect snot samples using petri dishes suction cupped onto the drone. Cameras mounted on the drone also help scientists ID whales and study their physical behaviors. So how does it work? Snotbots are piloted by drivers that see through cameras mounted on the drone. The drone is coded with artificial intelligence, which allows for the drone to learn. This allows it to better adapt to complex situations and allows for higher success rates compared to current methods. In the past, scientists would collect samples by taking it from an already injured or dead whale, which could compromise the whale's safety. This made it hard for scientists to collect data and didn't give as accurate data as living whales. The current method to collect whale snot is someone goes out by boat and stays by the target whale, and they attach a petri dish to a pole and hold it over the whale's blowhole. This made it difficult to get data if the whale was swimming, and it was also dangerous because the whale could possibly tip the scientist's boat and it could harm the researcher. So the reason the snotbot is needed is because many species of whales are endangered for a multitude of reasons. Some of these are because of habitat shifts, climate change, human interference, contaminants in the water, and poachers. The snotbot presents a harm-free way to collect lots of data on many different kinds of whales. The snotbots collect snot samples, and allow for scientists to check on the whale's condition, and they can infer what is positively or negatively impacting the whales in that area. For example, if they went to a group of whales and they took snot samples from them, and they find viruses and bacteria in the snot samples, they can infer that there are environmental toxins in that area. Some benefits to snotbots is that it provides a much wider range of data. Drones can go farther out than normal and allow for more collection because they're more efficient. It's also much safer because there's not human risk and they don't have to physically put themselves near the whales. And the best part is the whales don't even know that the drone is there. It just flies through and doesn't impact or harm the whales in any way. And it also provides very accurate data because of the whales living, and you could check multiple whales for comparisons. And it also allows snot collection in hard to reach places by boat. So I'm excited about this because artificial intelligence has become a leading factor in innovation in many fields of work. AI is being used in many places from farming to finance. And I believe that AI will continue to expand and see more widespread use in unique areas such as this one. The snotbot is a great example of an innovative way to use AI to help improve the world, which is the group that made the snotbots is called the Ocean Alliance, and they are looking for innovative ways to apply technology to help protect the ocean's ecosystem in harm-free methods, such as this one. And then these are my sources. Thank you for listening.
Awesome, wonderful. Thank you so much. Round of applause. Great job again. And for the third time today, I already had the privilege of hearing this presentation and asking my questions, so I will open it up to the floor. I love this project. It's just so great. Anybody have any questions? Brenda.
So do you have any idea how they clean or maintain the drones?
So after the drones come back, they take the petri dishes and they collect the samples and make sure they're fine. And then they just completely wash the drone because it does get a little gross because they have to fly through it.
Any other questions? Matthew?
Of course, I don't want to dominate, but thanks for explaining. I was so intrigued by what you were going to be talking about when you talked about Snotbot. So it is a great title. I was intrigued by what you said about the use of AI during the flights, and I'm involved in the aircraft sort of drone business myself, and just interested in sort of what is the AI layer and what it is that you're doing there with that.
So the AI is used to like detect like the whales and also like identify the like target whales, so it helps the drone be more accurate and like allow for higher success rates.
Okay.
Great. I think I saw, Jennifer, did you have a question? Or someone raised their hand? Okay. Anybody else have a question for Ethan? Mose.
You said that the drone doesn't bother the whale, but the drone is the kind of loud aircraft. Was there is anything mentioned in the research if it's scared the whale?
So
or nothing at all mentioned about that?
they've actually tried it, and out of the, I think it was 50 trial runs they did, only 3 of the whales showed any signs of even noticing the drone at all. All the other 47 didn't notice it at all. They just completely were unaware that it even was there. And then the 3 that were impacted weren't heavily impacted. They just noticed it. And that was just what the results showed.
Yeah, and can you talk again about today about where this is being done and yeah, how long it's been being done?
So this is a pretty recent project, but it's being tested in many different oceans, but the main one it's being tested in is the Atlantic Ocean right now on the east side of the US.
And do you see yourself pursuing whale snot collecting in your AI future?
I'm interested in the project because I'm interested in the AI field, but I probably won't continue with the, yeah.
Wonderful. We have one more question and then we'll move on to the next presentation.
Just wondering if the birds attack the drones, because it happens in the drone delivery space, and when whales surface, a lot of seagulls and others are waiting for the fish there, and I wonder if they see that as a food threat for them.
Yeah, from what I've seen videos of it in progress. I've read reports of it. I haven't seen anything about bird attacks on the drones.
Yeah, again, another thing I didn't think about. Great job. Wonderful presentation again. And thanks everyone for the questions. Yeah, I just love this project again. I'm going to say I really enjoyed learning about this. And I actually told my 8-year-old yesterday about this project, and he was fascinated. He asked me a ton of questions, and half of which I couldn't answer. So maybe I'll send him your way. So yeah, so next up, Jennifer, were you able to figure out what's going on? Okay. Great. Oh, yes, we can see your screen. So yeah, take it away, Jennifer. And this will be our last presentation for today.
Oh, whoops. Okay. Sorry, I had some technical difficulties earlier, but I changed my settings and I'm really excited to be presenting today. So hi everyone, my name is Jennifer Luo, and today I will be presenting a research project on fabricating an artificial heart fit for human use. And this research was conducted by bioengineers from the Harvard John A. Paulson School of Engineering and Applied Sciences. So I was originally interested in this topic because medical research really appeals to me. And as soon as I saw the title, I was very intrigued to learn more about how people were able to create an artificial heart, because hearts are the most complex and arguably the most vital organ in our human body. And to be able to fabricate this incredibly complex organ is not an easy task. And also, as you may know, that the leading cause of death in the US is heart disease. And part of why it is so deadly is because the heart, unlike other organs, cannot repair itself after injury. And so the only cure to this disease is a heart transplant. And that is exactly why tissue engineering, which can ultimately lead to the fabrication of entire heart, is so important for the future of cardiac medicine. So to build a heart from the ground up, the unique structures that make up a heart have to be replicated. And this includes recreating these helical geometries that create a twisting motion as the heart beats. And this twisting motion is something that scientists have long believed is critical to pumping blood at high volumes, but proving this has been very difficult because to create hearts with its different geometries and alignments is very challenging. But now these bioengineers have successfully shown and created an artificial heart. So moving on, how exactly did these scientists develop an artificial heart? Well, they created a new method of additive textile manufacturing, which is basically a technique that uses computer-aided design software to direct hardware and to deposit material layer upon layer in precise geometric shapes. One type of additive textile manufacturing that you may be more familiar with is 3D printing. However, the method used in this research is a brand new method that they developed called focused rotary jet spinning, or FRJS for short. And unlike 3D printing, which gets slower as features get smaller, FRJS can quickly spin fibers at the single micron scale, which is about 50 times smaller than a single human hair. And this is very important when it comes to building a heart from scratch. So the process of FRJS, the first step kind of works like a cotton candy machine. So a liquid polymer solution is loaded into this reservoir and is pushed out through a tiny opening by a centrifugal force as the device spins. And then as the solution leaves the reservoir, the solvent evaporates and the polymers solidify to form fibers. And then, as you can see in the first picture, a focused airstream controls the orientation of the fiber as they are deposited on a collector. And then the team found that by angling and rotating the collector, the fibers in the stream would align and twist around the collector as it spun. Be seen in the second picture below. And then the fibers are seeded with cardiomyocyte cells, which causes the ventricles to start beating just like a human heart. So this research obviously has a huge impact on everyone's lives, and it took a very large group of people to make this project happen, like mechanical engineers focused on the way the heart contracts, materials engineers focused on building fibers, and so many different people from different scientific specialties focused on other areas that were needed to create this heart. And as you can see in this picture, the first picture, there's kind of a model of a heart. And also the two pictures below, those are, it looks really cool when you can see like a video of it because it's like actually pulsing, which is like just amazing. And this research of building cardiac cells and tissues.
Jennifer, and we're gonna record that round of applause. Fantastic job. Great presentation. I really enjoyed that. Do we have any questions for Jennifer? I'll open it up here. And I'll actually just start off. I'm interested to know what inspired you to learn about this topic. If there's a story behind that.
Well, in general, I'm just really interested in the medical field. And so I knew I wanted to research something related to medicine. And I was just looking on websites, and this title just really caught my eye because, like, yeah, as I said, like the human heart organ is just so complex. I really wanted to know how they would be able to create an artificial version of it.
Awesome. Mose.
I know creating a heart is one thing, but making it work is another.
Yeah, exactly.
So how far are they in their research in making it work?
Well, they're still in the beginning stages, but they're actually really far into their research. They're like 19 years already into their research because they had to start with just building a model of it. But then after they started building a model of it, obviously they had to like put cells into it to make it start like actually pulsing and working like a heart. So this recent research is like a big breakthrough for them by using like this new method, focused rotary jet spinning, to like, and also just like their whole process right now is like their biggest breakthrough so far into making it work. But I would say there's still a long way to go to make it a full-sized heart, but they're getting closer and closer.
I was wondering, like, I remember recently reading about a project with the implanted of the pig's heart being implanted into somebody. Are there like, what other kind of competing or like what other technologies are out there, as you know, in the space? Do you know, how this stacks up in the field of ideas for heart technology?
That sounds really interesting, like a pig's heart, but I'm not really sure. This is like, for me, the first time I've ever heard of using something other than like a real heart transplant. So yeah.
I wonder if I'm remembering that right. Does anyone else remember seeing news about that? Or an organ of some kind? Maybe it was a liver.
Yeah, it was a big heart, and it's 2 surgeries so far, and both of them are still functioning with the assistance of machines. So it's not 100% even for that yet. Yeah. But I don't want the big heart.
Yeah, I don't know. I think I might prefer the synthetic heart that has 20 years of research behind it. I don't know how much. Yeah. So any other questions? You have like another minute or two. Kristi.
So Jennifer, in your research, did you look at any other creation of other types of organs to see how this compares or contrasts to other methods that are being used for different types of organs?
For this one, so it's also, there's a major focus on just like this new method of not 3D printing, of additive textile manufacturing. Like this method, they are using it to make hearts, but they're also using it to make like other products, I guess. I think they're also exploring using it to make like food wrappers or something, but I'm not sure about other organs. They're like focusing mainly on hearts, and also like specifically starting with like children's hearts, I guess, because I guess it's like smaller and easier to create.
Wow, that's really interesting. Michael, you have a question?
Yeah, I was kind of wondering, what do you think the long-lasting implications of this will be, such as when we actually will use this technology within like hospitals and in the real world? I guess just more like commonly within maybe the next 50 years or so.
You're breaking up a little. Did you get that, Jennifer?
Yeah, I think you asked like the impact of it like in the next 50 years. Yeah, so I think in the next, in another 50 years, they will definitely, I think they will actually be able to probably make a full size like child's heart, because just like there's like this new breakthrough is already like making it so much, like just getting so much closer. And yeah, like if you guys have time, you guys should definitely like watch the video and see how like the heart's like pulsing actually. So like that's really cool. And I feel like it will definitely save a lot of lives, especially since like heart disease is a huge cause of death. So it'll definitely impact all of our lives.
Well, I think that is a great note to end on. And thank you again, Jennifer, for the great presentation. I think we all learned a lot. And yeah, we were saying we wouldn't want to pink his heart, but I have to say, like, if you don't have another choice, I wonder if you know, like in that moment, if that is your choice, maybe you would think differently. I don't know. No, okay. Well, hopefully none of us will be in that situation ever, but great.
I'll be hoping Jennifer finish school and become a great heart surgeon and figure out a way to save me.
Yes, exactly. So yeah, that wraps up today's session. I don't know, I can't say thank you enough. Thank you so much, everyone, for joining us and supporting our students, who, as you can see, all did a fantastic job. They really worked hard with this presentation and all summer, and I encourage you to go and check out their RePicture profiles as well and learn more about them and all the projects that they researched. This is just one of several projects that most of our students researched and published as part of their portfolio this summer. They have very impressive profiles. And yeah, if you ever have opportunities in any of your organizations, you now know of some really excellent students who you should definitely encourage to apply. So thank you again. Does anyone have any final things you want to say? Yeah. And yeah, with that, we'll close out the session, and we hope to see you again next year at students' final, if not sooner. Great job. Thank you. Thank you.